Morning, and thank you for coming. We're going to talk about microservices. We're going to talk about Kafka. We're going to talk about event-driven architectures today. These are things that I get excited about. This particular talk has what are, right now, to me, some of the most exciting architectural ideas in it. Like some of the coolest things I see going on in the world related to event-driven systems, and just kind of related to the way we're writing programs these days. So it's a thing I get excited about. The basic structure of the talk is I would like to kind of lay out and sort of remind everyone what a terrible idea microservices are and why we have done this to ourselves, and think through some of the bad solutions we have to all the problems that we've made. And then I'd like to talk a little bit about Kafka just as a platform, just sort of the basics of things, and then take with that, this kind of broad perspective on Kafka, take that and apply it to all of the terribleness. So the idea is you should be like 2/3 of the way through any good talk just in complete despair, right? And that's the idea. You just want to be low. And then, we figure out how to fix everything and everybody leaves happy. So that's always the plan. But that's what we're going to do. I always like to say this is my first time properly in Denmark. I have transited from the airport on the train up to Sweden before. Barely counts, but good to be here. And who is local? I'm just curious. Who's from this country? Okay, so wow, oh, hi everybody, most of you. Yeah. When I was checking in to the hotel here yesterday, there was a funny little accent thing that happened. I was checking in. I gave the lady my passport, and what I heard her ask is, "Are you married?" And I said, "Yes, I am. Thank you for asking." It was 29 years this last summer. And then she said, "Can I have your number?" I'm like, "Well, I'm American, and maybe we just think about these things differently. I don't know, but probably you can't." Turns out she was saying Marriott. Are you like a Marriott Bonvoy member? And the way she was saying Marriott just sounded like married, and I just go with the jet lag, and I haven't been sleeping so well and everything. So I'll accept a lot of responsibility for that. And she wanted my Bonvoy number, so it was totally on the up and up. And I, of course, explained all this to her. I thought you said, and that was super awkward. But anyway, it was a nice first visit to Denmark. Glad to be here. All right, let's talk about this. Onions. We're going to get back to the onions later. Don't worry about that. We're not going to. I forgot to really say anything about why there's an onion there, but there's a very, very, very important idea that we have to get a lot of stuff on the table before that idea, I think, can land. And it does have to do with onions, so don't worry. I remember I started my career as a firmware developer, actually, which is really, really fun. And that's a thing again, now that hardware hacking is really, in the last 10 years, has become a reasonable hobby. Everybody can be a firmware developer, but that's how I started. And then I after a few years of that, didn't really use the word then, but full stack Java web developer. And I absolutely grew up in the era of the monolith. Right, you just wrote a program, and it had a database, and it was good, and it was easy. And for fairly small programs, that's actually a very successful strategy. It's a good thing to do. But for big programs, monoliths get hard to think about, right? If you have this big, giant program, it's too big to fit the whole thing into your head. This is one of the things as a software engineer that we have to realize is that we are limited. There's this philosophical term I like, our noetic equipment, our minds, right? What you have to be able to think is only so big. And I think we tend to be, as a community, a little smarter than the average bear, but you're not that smart. And you can't get that big of a program in your head. And so one of the problems is programs are so big that you just couldn't reason about the whole thing anymore. And, we're not animals, so we structure code. When you build monoliths, you structure it nicely, and there's a module here and a module there, and maybe you specialize in this module and somebody else specializes. It has some internal structure to it, but you can't fit the whole thing in your head. And Also, we found that they tended to just be hard to change once they got really big. Maybe the deployment took a long time, and integration tests took a day and a half to run or something like that. And so there wasn't really, sort of coming into 10 years ago when the idea of continuous deployment and delivery began to become in vogue, at least as an elite practice. It wasn't really accessible for big, giant programs, right? So we broke our great, nice, simple programs up into little pieces. And the big problem there is that you are now suddenly a distributed systems developer. And that's there's a lot of bad life choices you could make. That's high on the list of bad things that you ought not to do. And just to illustrate like one of the obvious problems, we have those modules. You have this modular monolith. Like, you're not an idiot, it's going to be modular. We kind of make straw men out of monoliths, like, oh, it's just this big undifferentiated morass of code. No, it's not. There's pieces. And those pieces call each other. And for one module to call another module, how does that work? Well, there's the JVM and blah, blah, blah. But at the end of the day, there's literally hardware structures on a microprocessor that optimize that. There are machine instructions to make that work very, very fast. And it's incredibly reliable. Like if a call and return instruction don't work, that's tantamount to the computer just being broken. That's not a failure scenario that you ever think about. And it's so fast, you don't think about how long that takes. But now we've broken this monolith up into pieces. We have to get those, and they're running on separate computers. You're a distributed systems developer. Your mom and dad told you not to, but you did it anyway. And they have to be connected back with each other again, right? We have to reintegrate all of these separate programs that are running on these separate unsynchronized computers that are failing independently and all that kind of stuff. So there are, I will just claim, no good ways to integrate microservices. Again, it's a terrible thing. You've broken your program up into lots of programs, and there isn't really anything good about that. And clearly, we are accessing good effects, right? There's like reasons we do this. It's not just rank stupidity. All kinds of great reasons. I just want to highlight that this is not all upside. It's a new set of trade-offs, just like anything else we do. Okay, so there are no good ways to reintegrate those microservices. Alternatively, there are no good ways to integrate microservices. And maybe we can take a look at what some of those are. So this is just this little thing. So there's potential for some hilarious physical comedy. I'm just gonna leave that there. Just some tension. Okay, integrating through the database. Like, we all know not to do this. I was giving a talk like this at a bank in Australia. It was last week. So the struggle is real when it comes to time zones. And I said something like, oh, we all know not to do this. And he's like, yeah, we do this. So never know. You never know. You just kind of have to lean into it at that point. So this is a little bit of a straw man. Most teams aren't doing this. This was an early solution because the database was there, right? You already had a database, and it seemed obvious you would just exchange data through the database. The problem is that this caused, it was an overly rigid way of coupling schema from or types from one service to another, and it made it so that typically these teams had to deploy all of their microservices together. You version one and you version, maybe 90% of the rest of them, and deploy them carefully in a particular order. So it's all of the pain of the distributed system and none of the benefits of independently evolvable pieces and decoupled pieces and things like that. So it was pretty bad. It violated this thing that the domain-driven design folks call the bounded context. Now, databases are not bad, and I really want you to hear me saying that, because I'm databases in the title, and maybe from the title and the abstract, you are thinking about where I'm going with this. Databases are a part of our lives, and they're not going to stop. They're good things to use inside services. You need them. Kafka is not one of them. I just want to be clear about that. But databases are not good for negotiating change. They're bad at that. They're bad for sharing data between services. I think as an industry, we've discovered that we can move on. And in fact, we have moved on when it comes to integrating microservices to this synchronous RPC-based mechanism. This is what most people think of. By default, this is how your services talk, is via RPC. So the database integration problems are largely ameliorated. You do have still schema contracts between services. A service needs to know what it's accepting, and somebody who's calling it needs to know what to give it and what to expect back. But the ability to evolve those independently is a little easier, because you can have these interfaces be a little squishier than a database table. Also, and I think this is why RPC has been so successful in terms of so broadly adopted. I don't really want to call it successful, but I want to call it broadly adopted. Is it's just natural. Given if you're using an imperative language, and if you're a functional programming person, this does not apply to you. By the way, if you're a functional programming person, you already think most things that people say don't apply to you. But you know who you are. If you're like me, basically an imperative person who's kind of toyed with the functional things, then RPC-based integration just feels as natural as breathing, right? It's even the APIs make it look like you're just calling methods. It's fine, it's just a method call. And there's all this network stuff, and things fail, and those failures become interesting, and a lot of the patterns that we see evolving around microservices development, or some people just say cloud-native development. There's, by the way, a great book called Cloud Native Patterns by a lady named Cornelia Davis. I just interviewed her on the Confluent podcast a few weeks ago. It's not live yet. Shameless plug for the Confluent podcast. The whole introduction thing, I forgot that. My name's Tim, and I work for a company called Confluent, and I do developer relations at Confluent. So that if I talk about that might happen. Anyway, the podcast is that podcast episode with Cornelia was so fun to actually interview her and to record. Great guest. And we talked about the patterns in her book, how a lot of them have to do with solving the problems that arise when you've got programs that are calling each other synchronously. And there's a fair amount in the book about event-driven architecture too, so it's not all just RPC stuff. But it feels natural, but problems happen. Problems come up, and now there's stuff we have to do to get around those problems. And I'm going to leave that as sort of a vague, there are problems, and we won't dive into that. The other nice thing about RPC-based integration, though, is that there's a lot of request response in our world. When I'm a user using a web front end or a mobile front end or something, like my life is largely synchronous. I tap things and I wait for the spinny thing, and then the box turns green, and okay, good, I can move on. That's synchronous. There's a lot of asynchronous interaction as well. I might get an email saying, oh, wait, actually, sorry, that was out of stock. That's asynchronous. But there is this kind of request-response life, and services that call each other. That just all works. Everything can be synchronous, and you don't have to think about things being asynchronous. That's nice. Again, I spent a lot of my last 2 weeks talking to bankers, and there is just so dang much messaging and synchronous stuff in that world, and so this makes that easy. I was getting ahead of myself earlier. There are these problems like, say, cascading failures that attend large synchronous networks of independent services. Here's a question, though. There's a smell here. Like, now that we've made all these services and all these programs running independently, and they're doing things, and it's hard to figure out what's going on, you have to debug the system. What do? Make a log. Well, isn't that interesting? We should probably pay attention to that. So, I should probably make more logs. Anyway, I want to talk about event-driven microservice integration. And later on, I want to show you a very trivial e-commerce microservices estate, and I want to refactor it step by step from synchronous to asynchronous, or from RPC to events. And I want to propose that the whole argument here is that integrating services through events, by having them exchange events, is a cleaner solution and has some properties and lets you access some phenomena in your architecture that you want to access. And so this is, it's the last one's always the good one, right? You have dumb idea, good idea is how you organize lists. And this is what I'm saying is the good idea. So let's talk about what events are. Well, an event in the context of business software is a narrative that elements of the system share that describes the way the business unfolds over time. Something that happened. It could be anything. When I'm talking to people who are very new to thinking about event-driven systems, the Internet of Things is always the go-to example. Like you've got this network of smart thermostats, and they're phoning home once a minute to report on the temperature and what's going on with the HVAC system and all that, right? That's just easy to think about, oh, those events, or monitoring power lines or smart cars, or these IoT things are easy to think about. Just about anything can be modeled as an event, and we'll see that. Any user interaction, any state change in a business process, any of these things. An event also, if you kind of break it apart and think, what's an event made out of? It's made out of two things. It is notification. That is like the when-ness of the event. The event has happened at an isolated point in time, and action ought to be taken. Something ought to happen as a result of that. There's also state in an event. It's not just, here's this delta function out in the universe saying something happened. There's an event in time, and here is some state that goes along with that event. And that state is usually small-ish, right? And when you get to really brass tacks implementation things inside of Kafka, smallish means, a megabyte for a lot of people who operate Kafka, and hopefully you're using a cloud service for that as much as you can these days, but if you're operating Kafka, events that are larger than that start to make people nervous. If you look at really, experienced Kafka admins, they don't like big messages. But there's state. There's actual data that goes along with an event. Here's another very, very important property of events. And I guess I'll start before I actually say it. Think about events in your life, right? Events like speaking words. You say something. That's an event. It's an event that you create. And maybe there's been a time in your life where you've said words, maybe to a loved one when you were in a bad mental state, and you wished later on that event had not happened. Right? Like you wish you hadn't said those words. What do we know about that? Can you make those words go away? You can't. Events are immutable, sometimes tragically immutable, right? You could always produce a new event later on, like a compensating action. That's an option. And often that works, happens to everybody. But events are immutable. This is important. It's definitely true of real-life events. It has to be true of systems that model events because you can't change the past. You want to keep a record of what has happened. You don't want that record to be editable. And in the case of Kafka, whose basics we will now explore, yes, events are stored as immutable things, and they're stored durably for arbitrary lengths of time. That can be, the default famously is 7 days, but there's just nothing 7-daysy about Kafka. It can be infinity. You can have it store data forever, you can have it store data for an hour. Events have this lifetime, and that's just a data governance and storage cost sort of equation. It has nothing to do with the nature of events or the nature of Kafka. So, let's talk a little bit about this platform. Kafka started as a distributed commit log. It was just a way of logging events and remembering them. It didn't even do replication when it was new. People used it in production before it used replication. Blows my mind. But initially it was very simple. It was just this big distributed commit log, and you had this Scala API on the background because it was, 2011. And that seemed like a good idea at the time. So at the heart of Kafka still, this is the fundamental data structure and concept at the middle of the thing is there's this log. Now, there's this platform around it, and I'm going to visit all those circles on the outside of that box because I want you to know what those things do and how they've emerged over time. And I think it's very important, not just that we get this thing about event-driven architectures and microservices into our heads, but when you think about Kafka, if you think, yeah, it's this distributed messaging system, that's not good enough. You're better than that. And there's a broader platform that you should be aware of. And the boundaries of that platform are constantly expanding in interesting ways as this thing grows. So anyway, logs. What do we know about logs? Well, when you write to a log, you put stuff on the end, and you don't change it. You don't go back and change things. Like I said, they're immutable, and messages are always appended to the end. It's just like a log file. If you go and edit a log file, what are you? Criminal. You're a criminal. You're covering up a crime, probably. Maybe you're just a conspirator, but most places that makes you a criminal too. What? And the fact that these are durable, right? That's one thing that differentiates Kafka from a messaging system. This is actually data storage. It's data infrastructure. Another thing, and sort of an implication of the fact that it's storage, is that we can have lots of consumers that can be reading from their own position in that log. I can create some new program that, I've got this log of whatever. Say it's sales. Say it's validated orders for my e-commerce website. That's this log, or we call it a topic in Kafka. Well, those are stored. That's not just buffering from one place to another in case something goes down or we get ahead of ourselves or something, but it's actually a record of the things, and I can now create a new program, say represented by Fred. Fred goes through and wants to read all those orders and figure out which customers are in our MVP program and get the notification that they get a discount or something like that, right? That's just some brand new thing that I might stand up based on data that I've got. And so that insight there is that this is a record of things, and there can be many interests on that record, many different individual programs doing different things, which we would call microservices, probably. Now, what's bad about logs, I'm sort of extolling the virtues of logs, just like sometimes we extol the virtues of microservices, and I started by saying that they were awful. What's awful about logs is reading them. What I can do is I can scan. That's what the API gives you. That's the Kafka Consumer API. I can seek to an offset, and that, by the way, is efficient to do. Reading, it's essentially a constant time operation to seek to a particular offset. It's definitely not a function of the size of the log. So I can just say it's constant time. And then I can read the next message and the next message and the next message. I can't go get all the messages for the thermostats in central Copenhagen. There's no such thing. I can just read. And that's a terrible way to live. So we're going to need to do better things than that. This is kind of an architectural substrate. This is not our solution for how to read data. Kafka lets me split these logs up into pieces, and I can have a cluster of lots of machines, and I can have a little piece of each log. Say break one of these logs up into 5 partitions, and I can put those partitions on different brokers, and thereby scale out storage and reading and writing and all those things. I can have many producers writing into that topic. I can have many consumers reading from those topics. And those are the fundamental, everything that talks to a Kafka topic is, at its bottom, a producer or a consumer or both. And you actually have access to these producer and consumer APIs. There's the native one that comes with Apache Kafka is Java, and there's a number of other supported libraries like Go and Python and C and .NET languages, and kind of, in terms of community drivers, every other freaking thing there is. There's probably several options for you. If you're like Ruby or JavaScript or these things that haven't really entirely standardized yet, you have to pick which one you're going to use, which is the bummer. But there's broad language support for the producer and the consumer. And everything, all the layers we build on top of that are fundamentally, at the bottom, that interface. That's the only way you talk to Kafka, is you produce or you consume. Connectors. Now, neat things have happened in Kafka as a community and as an ecosystem, and that's that, okay, we made this log thing, and we had this producer and consumer API, and we made you use Scala, and it wasn't nice, but it's Java now, but it's people found patterns emerging, all right? They found, wow, this log thing is a great abstraction, and I like using it, and I'm building my system around this distributed log and getting some neat things going on. But I have these legacy systems that aren't Kafka, and I don't get to modify them. There's this database out there, and I want to dump stuff into Elastic and S3, and that's the world, right? There's all these things. And so people would write bespoke data integration code that just, maybe polled the database and produced a record into a topic when you saw a new ID, or consumed from a topic and wrote it into an elastic index. And like everybody's writing this code, which is not good because that is undifferentiated framework code. It makes no difference whether you write it or the equivalent you at your company's nearest competitor writes it. You are not ahead. You are not serving customers better as a result of you writing that code. The problem, as we all know with this kind of code, is that it's fun because it's just us, right? There's no business stakeholder telling you to do something that is frankly stupid. You just get to make the code beautiful, and there are no dumb special cases. It's like this, platonic sphere floating in the heavens. But it's a trap, right? You don't want to spend time writing that kind of code because you get caught. And you never get to finish it and all that kind of stuff. So Kafka Connect emerged as the official solution to this kind of thing. And it is this framework that runs on its own servers. So it's like this extra server process that you stand up on this little cluster that runs outside your Kafka cluster. And then you drop jars in it, and you drop little configuration, little blobs of JSON in it. And it will say, oh, okay, there's a database out there. Here's the credentials that are in my JSON config. I'll just read from it, and I'll produce into this topic. Or I'll consume from this topic, and I'll dump into this Elastic cluster. And so it's this declarative way of getting that done. You don't have to write the data integration code. Huge library of connectors, and a big win, right? Because it can be fun and diverting to write that kind of code, but doesn't make any sense to the business. That should just get done once, and you should use it. Down on the bottom, those blue circles, the producer and consumer are, like I said, everything, even Connect. As far as Kafka knows, as far as the brokers know, that's just a producer and a consumer. The cluster doesn't know what Connect is. Just stuff is coming in and stuff is going out. And that, if you're writing code, the services you run, and you're just putting stuff in and getting stuff out, that's a little brutal over time. It's kind of like writing business software in assembly language, which would be fun, but nobody does it because you can't make money doing that. And so anything sophisticated that you're reading, any sophisticated read operations you're doing, for example, maybe I'm consuming from one topic, but then there's this other topic that has entities in it, like users. Every time somebody updates their user account, they put a message in the user topic. Well, I kind of would like to turn that into a lookup table. I want to be able to look stuff up, and maybe there's this other topic that has a user ID, and I want to go to that lookup table and enrich it, produce it to a new thing, and maybe group by postal code and run an aggregation over the group. This is not exotic, okay? It's just simply not hard to imagine that you're going to do this, because you are, and you have to do all that by yourself with the consumer, and that kind of is not fun. Again, you will write a bunch of framework code. You will develop your own internal stream processing framework. Don't do it, because there is one, and that's called Kafka Streams. So Kafka Streams, if you're writing code in Java, is this part of the platform that has all that stuff, and a lot more. There are lots of thorny distributed state management problems that arise when you start really thinking about how to scale a stream processing app. There's just a lot of ugly frameworky things. There's time windows that usually come up when you're aggregating. Like I want to know the average over the last 10 minutes. Sometimes data arrives late and like the window closed and I got to go back and update the last. You don't want that. It's not what you do. So Streams is the engine that does all that stuff. Most, I could say with confidence, most Java shops that are building microservices on Kafka gravitate towards Kafka Streams. Non-Java shops, well, it's complicated, but there is kind of the next level up from Kafka Streams in abstraction, the language called KSQL. If I could draw your attention to the Confluent blog tomorrow, we have a super cool announcement about KSQL. It's just super cool. It's getting some new features, and it's interesting. Some new things are happening there. But it's this free, open, SQL-like stream processing layer that runs on top of Kafka. You just kind of look at that query, you can get an idea of what it's doing. Very much SQL-like, and does stream processing in a declarative way on top of Kafka. 'Cause all of the code you'd have to write to do that with the consumer would just be daunting. You wouldn't want to do it. take a breath. I did say questions when you have them. And so in case one has been percolating, I'll just step back. I'll let you think. You don't have to. All right, move on. Let's apply this. So I want to take this platform, and I want to use that to fix some of the problems we get with microservices. All right, now what's easy about microservice slideware, and to some degree the actual practice of refactoring a monolith into services, is that the functional decomposition is usually pretty easy. You know, you have modules in your monolith, and that's like a good start, but it's just, there are things, there's payments, and there's shipping, and there's order validation, and returns, and all these are good candidates for this little unit of functionality where it all is cohesive and coherent, and that's just not that hard to do. The problem is that the data doesn't play along. Well, there's lots of problems in terms of making these things run, but the data doesn't play along in that for most of those services to work, they need to share facts from some other service. And we've already said there are problems that attend to that. If you just, again, the thing that everybody thought first was, well, just share the tables and go get the things and have one big shared database. And that for various reasons, was not successful. And again, it's easy to laugh now because we have seen how badly it worked out. But that's a reasonable way to begin, before you know. And because we know that can't work, we now have this problem to solve where I have to get data sharing. We're going to use Kafka as this backbone between services, all right? What the services are going to do, ultimately, is they're going to produce messages into Kafka topics and consume messages from Kafka topics. We have to solve the problem of sharing data, and we have to, that's the big problem we have to solve. There'll be some other problems, like what we do about synchronous operations out in the world. We'll try and talk about that, how we bridge that synchronous, asynchronous gap, how we share data. And apart from solving problems, I'm hoping that there might be some good architectural benefits that arise, other than it's not as bad as the next option. Maybe there's some new things that we can get our hands around. I would certainly love that to happen. So here is a trivial, minimum viable microservices system with that does e-commerce. We forgot payments, but it's okay. That's going to come out in the next release. So it's viable for some definition of viable. We just wanted to keep it simple. So what happens is there's this web front end that user does a thing and says, I want to order, and some piece of JSON comes into an endpoint on our orders service. All right? And because, as I said before, we are not animals, orders has its own database, and it alone knows about that database. So it validates that order, records it to the orders database. Probably that service, that endpoint also has an interface for looking up an order by an ID, let's say, and sending that JSON back to the browser. It's most of what we do is we get little pieces of JSON and we write them to a database, and then we look things up from databases and we turn them into JSON and we send them on their way. That's kind of maybe 80% of our jobs. That sounds depressing. I'm going to get off of that thought. So anyway, it records the order of the database, and this is exciting and important work, and it then has to ship that order. So it makes a call synchronously, this is RPC world, to the shipping service. Shipping service records that eventually it's going to record that the shipment has happened. First, though, it just has a customer ID or user ID, and it needs to get user data from the customer service. So it's going to call that, so it has an address and a name, and it calls, okay, here we go, it's customer 24601, and reply comes back, that name is the House of Berglund in Littleton, Colorado, and that comes out of that customer database. Now, the customer service also has its REST interface to the outside world. So these services are not just talking to each other, they're also talking to a front end. The shipping service is going to be talking to some back end to cause cause side effects out in the warehouse, But the customer service, again, people can create accounts, they can look up their details, they can edit their details. All that has to happen on that customer services REST interface and has to be reflected in that customer database, which only the customer service has access to. And this works, but we have the problems that attend RPC-based integration. So a piece at a time, I want to change this from the synchronous world into loosely coupled asynchronous microservices talking through Kafka. Let's see what happens. First, we will break the connection between orders and shipping. Now, order service really is just a validator, okay? And when it gets a validated order, it produces it to a Kafka topic. It's still going to need some kind of way to do key lookups on that, because people might still ask for, what's order 600? And so it's fine producing it to a topic. It still has that database-like thing. We can come back to that in a minute. But it still needs to do key lookups on orders. That's fine. But its job is just to validate, produce to the topic. If that database is, say, a Postgres instance, here's an important thing. That Postgres instance has to be a materialized view of what's in the topic. It's important that we make that topic the system of record. This is a record of the orders. This is where the true orders are. Because reading a log, as I said, sucks. We don't want that to be the end of the story. There has to be a way to look at those. And so if that database is a local Postgres instance, then that is being materialized, probably using Kafka Connect, from that topic back into that table, so now we can see those things. There are other more consistent solutions to that. We'll get to that later. The point is, yes, there's a database there or some sort of way to look up keys. But what that service does is it produces topics, it produces messages to the orders topic. And then the shipping service consumes them. And it does its work. It goes on. It's still synchronously coupled to the customer service. We haven't fixed that yet. But it gets this new unit of work from the orders topic and does its thing. Rather than being called, it consumes from a Kafka topic, and that's fine. And typically, when you're doing this, you produce to a topic, you create a new topic and you produce to it with a particular consumer in mind. Maybe you're even writing that consumer, right? You're thinking point to point, and that's totally fine. But don't think too point to point. I find this when I talk to, I really love this, by the way, what I'm doing. I love this. Another thing that I love in my job is sometimes I get to sit down with like a group of architects, like 5 or 10, and they tell me, here's what we're trying to do in our business. And it's never this clean. Like, I made this up so that it would be easy to understand. It's some bizarre thing that you're like, I don't even know how this maps onto event-driven architecture. I'm probably 10 seconds away from just failing and walking out of the room. And usually come up with kind of something, but it's neat because you just get the whatever of some arbitrary business and there are things they're trying to get done, and you're trying to figure out how all this works. And very typically in those rooms we're having this discussion. People migrating from a synchronous or kind of messaging-based mindset, when they're thinking about event-driven systems and producing an event, that orders service, like you write orders in the minimum viable system thinking about shipping, fine. Maybe you even write the shipping service. Fine. But when in the order service, when you produce that order, you really have to be hands-off about that. This is almost like a personal discipline. Like you're saying, here's a thing I've done, and I'm going to trust that somebody else picks it up and does the right thing. Or you can be that kind of person who puts it there and then goes and checks on it and makes sure it happens and asks and asks and asks and says, give me a notification back when you're done. You're not as much fun to work with if you're that kind of person. And that's just an important thing that we bring to event-driven architecture also. You put the thing there and you let it go. Obviously, the business needs to know if things aren't shipping. This does not obviate all observability concerns across your system. But from a service perspective, you let it go. It's just like the song. And the other thing that happens here is I was thinking of shipping when I wrote that service, but who else might care about validated orders? We could brainstorm, and that would be okay, and we'd get somewhere, but because of the limitations in our noetic equipment, as I said before, we would only do so well. Somebody else down the road in a future version of the business with a different perspective is going to think of something else to do with that data. And a new service can sprout from this fertile soil of a log of events. And so just with this one simple step, we have gotten a step towards an evolutionary architecture. There's other things that we have to do to unlock that, but without this data infrastructure, I think you are really hampered in making that happen. So when you've got services that are talking through logs, new services can evolve in ways that they might not have otherwise. You just have a shot at this sort of ecosystem or marketplace approach to services rather than a top-down designed approach to services. A top-down design is great. We do it all the time. It's just you have to keep that limited because you're not very good at it. We're only so smart, and so we have to give it to other people to do new things, and that's what this does. All right, we got to fix one more interface. We have 8 minutes. We still have to talk about onions. And that's this. So now shipping and customer are decoupled. But what happened here? I added, I am not calling customer service anymore for shipments. Remember the data sharing thing? Shipping needs orders plus users. How does it get them? Well, now when there's an update to a user, the customer service produces a message to a topic. This is a topic not really of events, but it's like a change log of the evolution of entities over time. You just put a new one in there. The key is the user ID. The value is a serialized user object. And that database that it has is probably a Kafka Streams thing called a K-table. And that's this in-memory, you could scale it among multiple instances. If it's a big table, there's a scale story that I'll spare you. But it's this in-memory, basically key value store where I can very, very efficiently look up messages in that topic by key, which is a new thing since before. Remember, with a log, all I could do is scan it. Well, now I could kind of turn that log on its side, and I've got a table. I've turned a topic into a table, a log into a table. And because that log is of immutable events, I can materialize that table over in the shipping service and not worry. I haven't really made a copy of a table in the relational sense where they're mutable, and if I change one, I have to change the other, and I have to think about distributed transactions, and better to get a different job than do that. I've got this log of immutable things, and I can materialize that tabular view anywhere. So yes, shipping service does have a copy of users, and it's a good thing. So that's how I solved that data sharing problem, and kind of unlock anybody to be able to have a view of the customer if they need that. And again, I fully appreciate that I am being hand-wavy about the scale implications. At large scale, there are interesting questions. At even pretty moderate to large scale, this is very solvable. There's a very good scale story here, like there is all over Kafka. Now, what have we done? Well, some stock photographer, is it dill or rosemary? It's hard to tell. But it's plastic. I don't even know where I'd get plastic dill. Like if I wanted some dill, that'd be easy to source. I'd go to 5 minutes away. I don't know where you'd get that, but I just am so upset that I have to redo this picture with my own fresh ingredients. Anyway, onions are a part of this, and databases are a part of this. And I think databases are like onions in one important way, and that is that they have layers, and some of those layers make you cry. So on the outside of the database, what do you see? You see an API that we all know and love, and we don't just know it in the sense that we're familiar with it. It's like an API we know. We can write SQL. This is a common skill. And any database that has this interface is at least approachable, right? That doesn't mean that the Postgres command line interface is easy to use. It's not. But SQL is SQL, and it's a good way to think about relational data. And by the way, I'm just constraining this to relational databases. This doesn't need to be that, but let's just go there for a minute. So peel that layer away. Peel the SQL layer away. What do you get? You get tables. What a nice data model. They're strongly typed. They are easy to change. You can index them in ways that you can't index a log ever, right? You can assert constraints over them so that various invariants in your system will be enforced even at this level of the data model. And you get to totally customize it, this way of representing the world. It's all up to you. It's great. Peel this layer away, and this is where you start to cry. And not everybody has been here with a database. If you have, you know. And if you're a DBA, or have been a DBA, this is it's a professional responsibility of you to have looked at the storage engine. If you're not, like maybe something happened and it's a dark time and like we can get a drink and talk about it. But this is tough. This is where you get to B trees on disk and extents and pages and the whole update in place thing that databases have to manage, relational databases have to manage, and it's tough. And it's best not to live there because there's a lot of crying there. Peel this away and what do you get? You get logs. Yeah, you get logs. And it doesn't matter what kind of database it is. That's the thing. I'm talking about relational databases. Go ahead. Do this with Cassandra. Do this with Mongo. Pick a graph database and do this. I don't know. Find an XML database. If it's a thing that you change, the mutations are recorded in a log. And then what happens? Well, we've already established that reading a log is awful. So the database essentially builds up these materialized views of what's in that log. And it builds them to conform to this data model that you've described and to satisfy performance contracts that it needs to satisfy so that it is pleasant and sensible and fast to read and write this data rather than interacting with this log directly. So the services that we refactored, we have orders and shipping and customers and fraud detection and MVP program and all these things, all these services. What are those? Well, if they're all interacting through Kafka topics, it's kind of like they are materialized views of data in a log. The log is a system of record, and we build up these materialized views to satisfy some data model that we're presenting to the world. These services have outside interfaces. They have a data model. They have certain performance contracts we want to enforce. So we're doing that same thing. That is what you're doing when you're building microservices. You're not just writing microservices because somebody said it was cloud native and you should. Right? There's all kinds of amazing architectural benefits that you can access here. And what your whole scheme amounts to is you're building what we call the inside-out database. You are kind of building a big custom-made distributed database. It's not a database that anybody else has ever heard of. It's not some new spin on a relational database or a document database or something. It's an application, but it's like this highly customized database that you present to the world. And I just think that's really cool. That is, to me, the most fascinating architectural thing that's happening around Kafka right now. Thanks for being here.